Hello, Westhill scholars. Let's take a look at our unit on chemistry. We started with the very early view of what what scholars thought about the world and how it was made up. Well, the very first guy we looked at again was this guy named Aristotle. And um, if we recall, what Aristotle thought was everything was made of earth and air and fire and water, and he thought that everything had some portion of these items in there, and that was what made up matter. We looked at the idea that matter was anything that um, had mass and volume that took up space. So we looked at the ideas of you being matter, the chair being matter, the table being matter, the world being matter. We looked at air actually being matter, even though you couldn't see it. We looked at all what was not matter, so the idea of thoughts. Although they fill our head, so you'd say there's some volume, but there's no mass. Thoughts are not volume. Ideas are not volume. We also looked at the idea of fire. Fire is a form of energy, just like the sound of my voice is a form of energy, and so that is not matter. But that doesn't mean that my voice doesn't matter, because what I'm telling you here does matter. Ha ha ha. All right. Then we eventually looked at how the idea of the atom eventually came to be through a variety of different people over time, and we ended up at a guy by the name of Bohr. And Bohr had an idea of the atom, the way it looked, and arranging the atom. His idea is that all the protons were in the center, and along with some neutrons. And in zipping around the outside were these little particles that were called electrons. So protons and neutrons were in the nucleus and the electrons were on the outside. He had the idea that in the nucleus, the number of protons changed according to what element we were talking about, and so did the number of electrons. He decided that the electrons were arranged in shells. In the first shell, he called K, and then L, and then M. And in K, he thought that K could hold 2 electrons, that L could hold up to 8 electrons, and that M can hold 18, but is satisfied if it holds 8. And that's as far as we went in grade 9. So every element, every single type of atom had a different number of protons, neutrons, and electrons. So when you considered, for example, the um, when you considered, for example, nitrogen, and nitrogen has an atomic mass of 14 and an atomic number of 7. That means that it has 7 protons in its nucleus. That gives us the hint. So we know we have 7 protons in the nucleus. We also know that if we take 14 take away 7, we end up getting 7 neutrons. So there's 7 neutrons that hold the protons together. That's inside the nucleus of nitrogen. Now it also has electrons, and for the sake of grade 9, we are saying that all of our atoms we're studying are neutral. In grade 10, you'll start working with what if the atoms aren't neutral. But for now, we are. So it's the same. So it will have the same number of electrons as it does protons. So it has 7 protons, 7 electrons, and 14 take away 7 is 7 neutrons. So 1, 2 on the first shell, and there's 5 left. 1, 2, 3, 4, 5. We group them in groups of 2 simply because it's easier to count. So we put 2 and 5 here. So we have a total of 7. This represents the atom nitrogen. The later there's a guy by the name of Gregor, um, Dmitry Mendeleev. Dmitry Mendeleev decided he was going to put these in some type of order. So it was the first periodic table, and he decided that his order was going to be like this. All of the elements that are in columns have the same number of outside electrons, and all of the are missing electrons, and all of the ones in the rows have the same number of shells. We'll try this again. All the ones in the rows have the same number of shells. It's not appearing to work very well. There we go. All of the ones in a row. So let's take a look at the columns first of all. So we know that hydrogen has one outside electron. We know that lithium, sodium, potassium, they all have one outside electron, and therefore they're going to behave the same way. We know that hydrogen will fill up the first shell, this one will fill up the second shell, sodium will fill up the third shell, and potassium will fill up the fourth shell, and so on. Therefore, all of the chemicals that are in the columns, they are called families because they will behave in similar fashions. And the elements that are in a row are called periods because they use the same number of shells. After we looked at the periodic table, and then we started looking at joining elements together. So now we kind of have an idea of how they fit together. We kind of looked at how do they join together. Well, if we take a look, remember our models that we looked at? We had hydrogen like this. Well, if you recall, hydrogen has one electron because the standard atomic notation for hydrogen is that it has one proton and it's got atomic mass of 1. So we know that it looks like this. There's one proton in the middle, and then there's one outside electron. Bohr said that an atom is not stable if its outside shell is not full or has 8. So this atom is not stable. And if you look at oxygen, oxygen is actually missing 2. Oxygen looks like this. So therefore, the pin for oxygen is 8 protons, 8 electrons, and 8 neutrons. So oxygen would look like this: 8 protons, 8 neutrons, and this shell would be full. This shell would have 1, 2, 3, 4, 5, 6. So it is actually missing 2 electrons in the outside shell in order to have 8 to be stable. So it's looking for 2. Well, hydrogen has an extra one. What if 2 hydrogens came together with an oxygen? So we have hydrogen has an extra one, hydrogen has an extra one, oxygen is looking for 2. There. Now that is water, and that's stable. That is why water is H2O. We looked at a wide variety of other types of elements when they got put together and determining what they were. For example, H2SO4, we know that that has hydrogen, sulfur, oxygen. It has 4 oxygen, it has 1 sulfur, and it has 2 hydrogen. If we put a 3 in front of H2SO4, now all of these quantities are multiplied by 3. So it has 6 hydrogen, it has 3 sulfur, and it has 3 times 4, 12 oxygens. One of the other things we looked at is we looked at the physical properties. Physical properties was the way things looked, the way they appeared, and the way they smelled, and the way they felt, how you would describe it. And then we looked at chemical properties. Chemical properties was the way that an item reacts with another when it's joined together with another item. We looked at physical change, was a change in size, a change in shape, and a change in state. And we looked at chemical change as if there was a new substance, and that new substance had to have new physical properties, sort of like the toast. We put the bread in, we toast it, energy is added, it's an exothermic reaction, energy is added, and the toast actually tastes different because it has different properties. The big thing that we looked at was the candle. If you recall the candle, and it comes up again in your exam, is the candle. We took C24H50 and we combined it with oxygen that was in the air, just like we do. We take glucose and we join it with oxygen to create energy, heat energy, movement energy. And a candle, we end up taking C24H50 and joining it with oxygen, and we produce carbon dioxide and H2O, just like humans. All right. Thank you.